Hi everyone, in this video I will introduce Panda, a concurrent scheduler for compiler-based tools. Compiler-based tools, or CBT, stand for utility programs taking source files as input and generating outputs with compiler arguments, which include but not limited to code transformation tools, program static analyzers, and so on. When executing compiler-based tools during compilation, users suffer three main problems: inconvenience of customizing the execution of multiple tools, mutual interference with the build system, and efficiency degradation due to the poles introduced by compilation dependencies. To resolve these problems, we propose Panda, a compilation-independent concurrent scheduler for different kinds of compiler-based tools. We separate the build process and the tooling process to handle the interference and the compilation dependency, and make it possible to customize the tool execution by storing and reusing the compiler arguments. Here is the outline of the demonstration. First, downloading and installing Panda. The Panda scheduler is provided as an all-in-one Python script. Users can download from the GitHub repository directly through the raw code link to this file. Then, add an execute permission to the file to make it executable. Second, generating compilation database. In this demonstration, we only show the most commonly used approach of this process. For more details about compilation database and how to generate it, please follow the link below. In this example, we use project BFTBD as the target project of executing compiler-based tools, and we use build-year to generate compilation database. The first step is to access the source code of the project and configure the project for compilation. Then, the build-year tool is used together with GNU-make to build the project and capture information of compiler execution during the process. And the captured information will be stored in a JSON file called compiledcommands.json. With the compilation database stored in the JSON file, we can now use Panda to schedule the execution of compiler-based tools. Panda provides rich built-in configurations that can cover the common sins of using utility functionalities in compilers and the popular tools built on the top of the clone compiler. These built-in configurations can be directly executed through Panda's command line arguments. Here is an example of using Panda to run syntax checks on the project with a different compiler other than the one used during compilation. The project is built with GCC, whereas Panda will invoke the clone compiler by default. In addition to built-in configurations, users can also provide their own configurations to run other compiler-based tools as they expected. User-defined configurations are JSON files describing the type of the tool and how to launch it. Here are two examples of user-defined configurations, one for integrated tools and the other for singleton tools. The plugin argument is used to pass the user-defined configurations to Panda. The configuration for integrated tool invokes clone to generate LLVMIR code. The generated files will be stored in the output directory. Whereas the one for singleton tool use clone query to match all existence of 4 statements in the project, the output in the stdout stream will be captured and stored in the output directory as described in the configuration. For concurrent execution, users can also customize the number of parallel workers, the sorting strategy for jobs in the work list, and the approach of measuring the job size. By default, the long job first strategy and the number of semicolons are used. Thank you for watching. For more detailed usages of Panda, please visit our GitHub directory.